Today we're going to calculate standard deviation, and you have two formulas here. One's for a sample size and one's for a population size. Really the only difference is that if you're dealing with a sample, you're going to use x bar in your formula and you're going to divide by n minus 1. If you have a population, you're going to use mu, which is your population mean, and you're going to divide by your population size. For these examples, we're going to be using the sample standard deviation. So what exactly is standard deviation? Suppose you asked your friends how many books they read over the summer and they gave you the following responses: 7, 2, 4, 0, and 2. We could calculate the mean of those values, or x bar, if you just add up the x values, which is each piece of data, and divided by the number of pieces of data, you'd get 15 divided by 5, which is just 3. Right? So if we place the line at 3 on this little graph we have here, what we're going to do now is place each response on the graph as well. So student 1 or kid 1, they responded that they read 7 books. Student number 2, they responded that they read 2. Student number 3 read 4. Student number 4 read 0. And student number 5 read 2. Standard deviation represents how far all your values deviated from the mean. It's the average of all of these distances. Right? And if you started subtracting these distances from your mean, which is 3, you'd get negative values, and we know you can't have negative distances. So in the formula what we do is we take our x value, here it was 7, and we subtract our mean, x bar, so 7 minus 3, we get a distance of 4. What we do then is we square these values, because if you did it the other way, you'd get a negative value, and you don't want negative, so by squaring them, we make them positive. All right, we're going to add up all these distances, divide by the number of data values we have, minus 1, because we're dealing with a sample, and then to undo this squaring, we're going to take the square root of that. All right, I'm going to show you exactly how to do that in list format. All right. So in order to calculate standard deviation, what we're going to do is we're going to set up a little grid like I have over here on the right, and I'm going to label the tops of each column as x, x minus x bar, and x minus x bar squared. And this summation notation right here, this sigma, means I'm going to take the sum of x minus x bar squared. So when I get to the bottom of this third column, I'm going to add those values up, and that's going to replace the numerator in the formula. Alright, so I went through and I listed my x values. That's the data I got from our friends, 7, 2, 4, 0, and 2. And we took those values and subtracted our mean, x bar, which was 3. So 7 minus 3 was 4, 2 minus 3 was negative 1, 4 minus 3 was 1, and so forth. We then took those values and squared them. Now it's important to make sure you include your parentheses here, because whenever you square a positive, the answer is positive, and whenever you square a negative, it's also positive. So all these values in this column should be positive. Right? And I'm going to add these up. When you add these up, you get 28. This value is going to replace your numerator. So we have the standard deviation is equal to the square root of 28. Right? N minus 1, n represents your sample size. There's 1, 2, 3, 5 of those. So 5 minus 1 is 4. Right? And approximate this, and that'll be your standard deviation. Alright, so we get sample standard deviation is approximately 2.65 books. Alright, whenever you do standard deviation, it always carries the units of whatever you're measuring, and this number represents the average distance each individual piece of data was away from the mean. We can also use our TI-83 or 84 calculator to calculate standard deviation, and I'm going to show you two different methods. Alright, if you hit your stat key and go to edit, you're going to be in a list format similar to what you see on the right there, and what we're going to do is we're going to enter that first column, 72402. Right. I've already calculated my mean, so I'm going to take, this is actually pretty easy, if you highlight the L2 and hit second 1, which is list 1, I want to take list 1 minus 3, because that was my mean, and hit enter. Then I'll subtract those for you. Highlight list 3, and here I want to take the values from list 2, so hit second 2, which is your L2, and I want to square those, and hit enter. And you'll see I have the same values. If we quit out of here and go to second stat math and take the sum. All right, I want to take the sum of list 3. Remember, list 3 is where that last column was. Hit second 3, and you'll get 28. Once you're here, just take the square root of 28 divided by 4, and you get your standard deviation. There's a second method too, using your TI-83 or 84 calculator. If you go back to Stat, Edit, and put your data values back into list 1, right, and go back to your home screen, and now go to Stat, over to Calculate, C-A-L-C, and do one variable statistics. Hit Enter, and by default it does list 1, but suppose your data was in list 2 or list 3, you'd have to put that, but by default it would do list 1, so you don't even have to put the L1 there. Hit Enter, and from here you can actually get a whole bunch of information. You can get your X bar, your average, which is 3. You can get your sample standard deviation, 2.645. Your population standard deviation, you can get your sample size, you can get your 5-number summary for a box and whisker plot. Alright? And suppose you're in Excel. It's actually a lot easier in Excel. You would just enter your data into a column, and then wherever you want to define the standard deviation, just hit equal sign, and the formula is STDEV, and put a left parenthesis, highlight the cells, close your parenthesis, and hit Enter. You can see we got the same thing, 2.6457. Alright.